Welcome to Build Up Roof's Damage Assessment. My name is Richard Herzog, and I'm an engineer and meteorologist with Hague Engineering, and I'm going to be taking you through our 6-part course on built-up roofing. Section 1 is on the components of the system. Section 2, some of the common installation and design issues. Section 3 will focus on some of the design and application issues you commonly see on built-up roofs. Section 4, some of the long-term maintenance and weathering issues that you will see. Section 5 is on wind and hail damage assessment, and Section 6 on more inspection techniques and some of the repair options with a built-up roof. First, we're going to focus on the components of a built-up roof system. This involves the bitumen that's used. This is the primary waterproofing element of the built-up roof system. The reinforcements, and also what is the typical installation of the base ply and the multi-ply built-up roof system. The most common waterproofing bitumen that's used in built-up roofing is asphalt. Asphalt is produced from crude oil, and the fractional distillation process produces a material known as asphalt flux. By further refining in a blow-still operation, they can make the asphalt into 4 grades of roofing quality asphalt. Type 1 is known as dead level asphalt, and this can be used on roofs that are anything from flat to up to 1/4 inch per foot. The most common roofing asphalt used is actually known as Type 3, and they call this steep asphalt, and this can be used up to a 312 pitch, although it can also be used on slopes that are 1/4 inch per foot or 1/2 inch per foot as well. The optimum application temperature for Type 3 asphalt is 425 degrees, but you get tolerance of 25 degrees plus or minus that, so the application temperature range is 400 to 450 degrees. If your roof is steeper than 312 and you still want to put on a built-up roof, there is Type 4 known as special steep asphalt that can go up to a 612 pitch. Let's talk a little bit about the characteristics of asphalt and how it performs as a roofing product. Molecularly, as we can see in the slide, asphalt has a long chain molecule, and that means it's not 100% stable. With outdoor weathering on a roof, there is some sensitivity of the asphalt to ultraviolet light, and it is slightly soluble in water, and these are the 2 of the things that do cause long-term deterioration of the roof. At room temperature, there is no distinctive odor to asphalt. However, when it's being applied at those hot temperatures at 300 to 450 degrees, there is an odor to that, and you've probably noticed that too just from going by road construction operations using hot asphalt too as you're driving. Are there safety concerns with asphalt? Currently, there's no particular safety restrictions to use of roofing asphalt in the United States. There has been a recent international study that determined that hot asphalt is potentially carcinogenic. So just as we go through future years, there could be some change in some of the restrictions to the use of hot asphalt in roofing in the United States, but those are not currently in effect. The other bitumen that you commonly can see used in built-up roofing is coal tar. Now, coal tar has been used in built-up roofing for over 150 years. Back in that time in the United States, we did a lot of our heating and a lot of our factory industrial production with the burning of coal, and that produced a material called coal tar flux. Then it was determined that this had great waterproofing characteristics, and this began to be refined as a roofing product, which is known as coal tar pitch. Type 1 coal tar pitch can be used on roofs that are dead level or up to a slope of 1/8 of an inch per foot. The characteristics of coal tar are somewhat different from asphalt. One is molecularly, it has a ring formation, different from that long chain we saw for asphalt, and this is a more stable type of molecule. And as such, it has lower sensitivity to ultraviolet light, and it is not soluble in water. Also, there's a characteristic of cold flow, meaning at some of the roof surface temperatures that can be achieved on a hot, sunny day, even on an older roof, the coal tar will soften and bubble and flow a little bit. And this can actually help to heal some small gouges or scrapes or problems that form in the roof. So all of these three things make built-up roofing with coal tar a very effective material. Now, what are some of the downsides to coal tar? Well, it does have a creosote-like odor that many people find unpleasant, and actually many people will have allergic reactions to exposure to coal tar. And further, it has been shown to be a known carcinogen, and so there are health and safety restrictions to the use of coal tar. Although, if you abide by those restrictions, you can still apply a coal tar roof today, although it's really a very small percentage of current installations of built-up roofs. You still may see roofs out there that are 15, 20, 30 years old that do contain coal tar. And so we're going to go into some of the characteristics of noticing if you are looking at a coal tar roof. The photograph in the upper left of this slide is showing a coal tar build-up roof, abbreviated as CT-BUR. With the gravel on it, you may not at first realize that this is coal tar. But in looking more closely at the photograph in the slide on the right, you typically see small nodules that can be known as raspberries or blueberries due to their size and shape that form on a coal tar roof just as it goes through these multiple heat-up cycles where the material will bubble up and actually form these small nodules. This slide shows a built-up roof with coal tar that was more than 30 years old, and even though it may not look that pretty, it did not leak even with little maintenance throughout its history. Coal tar roofs work best when they are dead level or nearly flat, because as that coal tar material heats up on a hot day, it actually can start to flow away from high points such as blisters or wrinkles or other higher areas on the roof. The photograph in the lower right of this slide shows an area where the coal tar bitumen has flowed away from the organic matte felt that's in the roofing, and it has started to deteriorate and wear through. So as an inspector, how do you distinguish if you're looking at a coal tar roof versus asphalt? One, you can maybe tell by the odor. If you have a sensitive nose and you detect that creosote-like odor, that would indicate coal tar, where an older roof that's asphalt should not have detectable odor. If you want to be even more sure, you could take a little piece of bitumen off the surface of the roof, whether it be one of those nodules that you find or a little chunk that's loose on the top surface of it. And if you test that in mineral spirits, again, this is a solvent that you can buy over the counter at the hardware store. Asphalt will dissolve in mineral spirits, and so as we look at that top photograph, the liquid will turn dark brown to black as that asphalt starts to dissolve. With coal tar, there might be some dirt and grime that comes off that changes the liquid from clear to a lighter yellow color, as we see in the photograph, but the coal tar itself will not dissolve. And so there's a pretty clear test as whether you're dealing with a coal tar or an asphalt bitumen on the roof. This is important to recognize because coal tar and asphalt are not compatible with each other. And so if it is a coal tar roof, you don't want to repair it with hot asphalt. When you use the two materials together, the coal tar may harden and the asphalt melt, and just the results are unpredictable, and just you want to keep the material compatible with each other on the roof. In addition to hot applying asphalt or coal tar, there also are some cold applied options with either an asphalt pitch or coal tar. And this is done with solvents, also known as cutbacks, which get the material thin enough that it can be poured at room temperature levels without heating. This has been done more in the last 5 years or so. And part of the reason is just to deal with some of the odor issues, either for the workers or for people that are in the occupied buildings that are being re-roofed. A cold applied system does not have the odor associated with hot bitumen roofing. Next, we're going to move on to the reinforcements that are used for the plies in the built-up roofing. They're either going to be organic or inorganic. Organic is a pulp paper-based material. And once hot asphalt is applied in the roofing plant to this, it soaks into that paper. And that is what is termed asphalt saturated felt. A next step that can be taken in some materials is to put a coating of mineral sand or talc on one or both sides of that saturated felt. And at that point, they call it an asphalt coated felt. So those are sold as two different products. With inorganic reinforcement materials, they're most commonly fiberglass for built-up roofing, though you can have mats that have polyester or possibly a combination between fiberglass and polyester. Then there are two levels of asphalt that can be applied to these felts. A full coating on both sides is termed asphalt coated felt. If you give it a lesser amount of asphalt to where it doesn't completely cover the surface, that is termed asphalt impregnated felt. In this, there's going to be small holes and voids in that mat material. And these are what are used when you're hot mopping the built-up roof, because that hot liquid bitumen will go through the holes and voids and will help lock the plies together and make for a stronger roof system. The first sheet that's going to be applied on a built-up roof is known as the base sheet. This is going to be the foundation for a built-up roof, and typically it's going to be a medium weight asphalt saturated or coated felt. This is going to help separate the built-up roof from the roof decking or the substrate, which may involve insulation boards or a prior roof system. The felt helps bridge over the irregular surfaces and cover over joints in the insulation board, and also will prevent any of the hot bitumen from leaking down into the lower levels of the roof or into the building. If the roof deck is considered nailable, and that includes a roof deck that also can be applied to with screws, then that base sheet is going to be mechanically attached. The base sheet is 36 inches wide and is going to be installed with just a 2-inch overlap, so essentially a one-ply installation. This is what's shown as the lighter gray material in the installation graphic being shown on the slide. Nails or screws would be applied every 9 inches along the lap. Important to notice that you're going to have to apply those fasteners through a cap that's got at least a 1-inch diameter to provide enough tear resistance to that base sheet. Every 1 foot then across our base sheet, you would apply those fasteners at 8-inch interval spacings. If the roof substrate or deck is not nailable, you can apply that base sheet through adhesive. And so in the graphic shown on this slide, we are looking at a concrete roof deck. First, an asphalt primer is put down, and then at that point you can apply the base sheet either through hot applied asphalt or some type of cold adhesive, such as a polyurethane adhesive. And that would give you your solidly adhesed surface to apply your built-up roofing felts to. Sometimes you would want your base sheet to allow moisture to vent from underneath it. This would be common for two different scenarios. One, if you're roofing over an old roof system that has had leakage problems, is believed to contain moisture, you would want to provide some venting of the moisture to come out of that roof system. Another can be for newer construction. If you're applying over cementitious materials such as lightweight insulating concrete that also would have a fairly high moisture content as it is curing. The vented base sheets will allow moisture to channel out underneath the built-up roof membrane, and then you would be installing one-way membrane vents, as are shown in the graphic on the slide, about 1 every 10 roofing squares, and that would allow moisture to escape from below the roof system without causing rot to the insulation boards or corrosion to the fasteners. In the photograph on this slide, we're looking at one of these types of venting base sheets. If you look at the left part of the photograph, that is the underside of the venting base sheet, which has granules applied in roughly square formations to the bottom of the sheet, but then there's channels in between the areas with granules, and that is designed as the avenue for the vapor to pass through and around that venting base sheet. Now we're moving to the plies that are going to be hot mopped and applied to make our built-up roof. In current construction, the most commonly used one is an asphalt impregnated glass fiber type 4 sheet. Again, that asphalt impregnated felt is going to have small voids that hot bitumen will be able to ooze through to help lock the different plies together during the installation. If for some reason the installer or designer wanted to have a heavier sheet, there's a material called glass fiber type 6 that would be a little more durable felt. Also, you could use an organic asphalt saturated felt number 15, and if you're going to do this, this would be a perforated style of felt that likewise would have those holes that the hot bitumen would be able to pass through during the installation. Once we start putting our built-up roof together, it's going to be alternate applications of solidly mopped hot bitumen underneath these ply sheets. That inner ply asphalt between each layer should be installed at approximately 20 pounds per square. Once you determine what the thickness of your roof is going to be, that helps set the exposure of the felt plies. Because the sheet is 36 inches wide and there's going to be original 2-inch overlap, 17-inch lap exposure indicates 36 inches minus 2 to get you to 34, and then divided by 2 shows 17 inches. If it's going to be a 3-ply roof, that lap exposure would be 11 1/3. A 4-ply roof would have 8.5-inch lap exposure. The photograph in this slide shows what would be the typical cross-section of a built-up roof once it's cut. You see the 3 plies of fiberglass mat visible, and then there is a lower ply that is that base sheet ply. So we call this 3 plies, so it's actually 3 plies plus a base sheet. The graphic on this slide shows us a typical 2-ply exposure. The lighter gray material in the upper right portion is our base sheet. The darker gray is our glass fiber ply sheets that are being installed. And it's showing that 17-inch exposure, and each ply you're trying to get 100% hot mopping coverage of the bitumen. A 3-ply built-up roof would have a similar type of design, just with a shorter lap exposure, 11 1/3 inches being exposed on here. This slide also shows a top surface being put above those ply sheets of a glass fiber cap sheet. That's not the only option. We're going to get involved later in these slides to the different surfacing options for a built-up roof. This is just one particular example you can have. As an inspector, can you tell how many plies are in a built-up roof? Sometimes you can. In the photograph shown in this slide, we see a very old and worn built-up roof, and the exposed edges of the plies are visible in the vertical lines shown in the photograph. By measuring the distance between them as a little bit over 11 inches, that determined that it was a 3-ply roof. In some cases, there might be sufficient loose and embedded gravel in the flood coat that you can't make that measurement. But if you look around on most roofs, you can find some areas where you can make that type of measurement to determine, are you dealing with a 2-ply, 3-ply, or 4-ply built-up roof. Slope and drainage is always a consideration when you're installing a roof. For new construction, the minimum slope is 1/4 inch per foot. In looking at older buildings, you may find that that's not always the case, but a existing building can be re-roofed if the roof at least shows positive drainage to the building perimeter or towards interior drains. The most common way of doing the felt plies is in a shingling manner. The photograph in this slide shows that the roof slopes down from right to left. And so the plies are installed parallel to the edge of the roof on the left. The water is going to go perpendicular to the felt plies. And that's the case when the slope is less than 212. On a steeper sloped built-up roof, 212 or greater, they actually will run those felt plies the other direction parallel to the rake. In the photograph shown in this slide, we have a steeper roof, more than a 212 pitch. And so they use the strapping method, meaning the ply sheets are applied parallel to the rake. This concludes section 1. Now it's time to proceed to your review and quiz. Thank you.